Okay, we're doing 236, a constant acceleration problem. What we have is a car starting from rest to vi of 0, and after some amount of time or some displacement, we want to know how fast it's going. So it's moving this way, but we don't know what the VF is. What we do know is that it's accelerating with an acceleration of 3 meters per second squared. And I'm calling positive to the right. I've called that a positive amount. Okay, so we're going to deal with 10 seconds later first. That's the easier one to deal with. So I'll draw a v versus t graph. It starts with an initial velocity of 0, and it's going to accelerate. And the slope of this line is the acceleration. So if I want to find the VF at some point after some delta t, like 10 seconds, what I'm trying to find is this amount here. So the increase in the velocity from 0 to VF is the rise, and the run is 10 seconds. So I know that my slope, which is the acceleration, is going to be whatever VF is over 10 seconds. So VF is 3 meters per second squared times 10 seconds. One of the seconds cancels with that one, and so I'm left with 30 meters per second. Okay, this is a little more straightforward than the second one, but the strategy is going to be the same. So we have a v versus t graph. Again, starting at 0. Again, we know the slope. We're looking for a VF at some point here, but we don't know what the delta t is. What we do know is that the delta x, which is the area under the v graph, is 10 meters. So we can express this area as the area of a triangle. So that's 1/2 times whatever delta t is times whatever VF is. That's all well and good, but we don't know what delta t is, so we can't really solve for VF. But we still know the slope. Still, the slope is the acceleration of 3 meters per second squared, and we can relate the slope to this VF and to the delta t. So in this one again, the rise is just VF, since it started at 0, and the run is delta t. Now we don't know delta t, but what we can do is solve for it here and substitute it in over there, and then it's gone, and all we have left that's unknown is the VF. So I'm going to multiply both sides by delta t. And then divide by 3 meters per second squared. Alright, and then I take this and substitute it in. So whatever delta t is, it's equal to this. Okay, and now I'm going to solve for VF. So I'm going to do that by, get some more space here. I'm going to do that by first, I'm going to multiply both sides by 2. So that takes care of this 1/2. And I'm going to multiply these VFs here together. I'm going to just collect them. That gives me VF squared. Okay, now multiply both sides by 3 meters per second squared. So that tells me that VF squared equals 60. Check the units. Meters are both in the numerator, so meters squared per second squared is what I get. So if I solve, I get VF is the square root of 60 meters squared per second squared. And the square root of 60 is 7.75 meters per second, because we took the square root of the units as well.